All right, our next presenter is Todd Waldorf. He is a GIS specialist in Pennoni's Design Technology Group, supporting GIS and asset management. He is experienced in creating and delivering geospatial solutions by implementing multiple applications and software such as GIS, Esri products, Global Mapper, MicroStation, and Sausage GXP.
Sausage.
Did I pronounce it right?
Good enough.
For database management, reporting, 3D feature extractions, photo interpretation, mosaic image processing, georeferencing, and emergency management. Mr. Waldorf has experience in GIS and remote sensing services, primarily mapping seagrass. He has been responsible for conducting tasks such as aerial photo interpretation, orthophotography, QC, and fieldwork in support of seagrass mapping for the St. Johns River Water Management District, the South Florida Water Management District, Florida Fish and Wildlife Conservation Commission, and NOAA. His other responsibilities have included geographic object-based image analysis and LiDAR classification and editing on bathymetric LiDAR projects. Mr. Waldorf is proficient in QA/QC, fieldwork, and custom digital map building. He is skilled in ArcGIS, CAD, AutoCAD, and EPA.
Thank you. Hi, everyone. Start this. Yeah, lightning talk, right? Exactly. I guess I don't have to worry about my timer so much. Hi, I'm Todd Waldorf. I'm from Pennoni and Associates. Pennoni is a firm, multidisciplinary engineering firm based out of the Northeast, Philadelphia, Pennsylvania, and they've extended their GIS segment down here into Florida. And I'm happy enough to come on board just over a year ago. I was doing heavily dense LiDAR work, no pun intended, before joining Pennoni. And now with Pennoni, branching out and essentially just offering all kinds of solutions to our different customers. We have ongoing relationships with many of our customers. And it's really interesting for me because we get to problem solve and see what we can come up with to deliver solutions for them. And in this case, we worked with the city of Clearwater, Florida, which was awesome because I grew up in Orlando and visited Clearwater, Florida, grew up there and everything like that. And we have an ongoing relationship with them. They contacted one of our project managers and asked them, hey, what can you do for us regarding our cemetery? So the project objectives were basically to take analog data and bring it forward into a digital format. So analog meaning that when the cemetery was created, it was created before there was digital GIS. And what they had was log books spread out currently throughout the city for whatever reason. They had about 4 different log books. Now there's burials that went all the way back to the 1900s, early 1900s. And some of the log books, they didn't even have records of many of the burials. So what we were going to do was just start from scratch and see if we can come up with a comprehensive database for them to work with moving forward. So what we did was we brought forward Esri field maps, ArcGIS Online, ArcGIS Pro, and also some different stakeholders that we work with. Now this is a lightning talk also, which is like really short, so apologize, I'm just gonna like speed through all of this. The methodology that we used was to basically send out a survey crew, understand the boundary, which was the entire extent of the property, understand the blocks, which were the blocks were the boundary, and then the lots, which were a smaller portion of each of those for identification purposes, and then within each block and lot were the individual plots, which were the burials themselves. So survey could only identify the extent of the boundaries, and then we went through with a field collection staff. We first sent through GPR, ground penetrating radar. They went through and they scanned, and any anomaly that they detected, the assumption was, of course, that it was a burial. So we identified the burial by marking off these flags right here. And they gave us 2 different points that later on we would buffer by 3 feet, which is the typical width of a casket. And the length of the actual identification with using GPR either wound up being translated into an adult burial, an infant burial, an urn. And so those made up 3 different burial layers. And we brought those forward using Esri field maps. We use a high precision, real-time kinetic GPS precision little instrument. It was about this big, and very so sensitive that just trying to get that thing to triangulate, and you want to keep it exactly over the point, became a challenge in and of itself. We wound up actually just using a little level bubble right over the point. Once we had that into Esri field maps, we then use to keep track of identification, we identified the headstones themselves. And then when we got back into the office, then we went ahead and we buffered out. And you can see what we did was we had the lines and then we buffered them out. And then this is the headstone layer right next to it with the names. So now what we have is we have an almost comprehensive data set of what's out there. Almost meaning that some of these burials didn't have a headstone, or the headstones were moved, or there was questions of that nature. So then what we have up here are our log books, where we went back and we manually went through each of the pages of the log books to try to identify anyone that we weren't able to do out in the field. Ultimately, what we came up with a 5th layer to do that, created a relationship in between them, and ultimately what that wound up giving us was the database that they can use going forward. They can spread it out through all of their departments, no longer have multiple departments throughout the city making updates, one logbook here, copied and made another logbook here, each having their own updates, them not bringing them together to make one database. Now it's a digital database, all verified. Some of the burials were outside of the boundaries that they thought they were, and now they know exactly where everything is. They're gonna, I believe that there was a right-of-way issue. They're gonna push one of the boundaries out even further that they found out from our survey. And then with this product now, it'll integrate very seamlessly into a larger cemetery database as well, which will make it easier for the public to look up their loved ones and family members and everything to that nature. So for me personally, just one of the many cool projects that I've been able to work on with Pennoni, and they are different from one to the next. And I just wanted to share that with you guys. Thank you. Oh, are there any questions? We have time for questions. All right, cool.
Well, is GPR refined enough to show you a skeleton in there, or is it just to show you?
No, this was my first experience with GPR, and it essentially would make like a concave kind of thing where it would find a point, and then the radar would kind of spread out, so they could find like a linear. That's why they're really good for finding the length, and then we just buffered out because they could find a 4-point GPR, but it would have taken longer and exceeded the budget. So it was worth it to the client just to do one end to the other and figure out, okay, we're getting a reading here and scan, okay, the reading stops here, and we're gonna assume that's the length of the burial. But maybe they could find a skeleton. And one of the creepier parts of the project was they had like a probing pole. So yeah, and they listened for a thunk to make sure they found it. Yeah. All right, thanks guys.